Hi guys, I'm Nivita. In this video, I'm going to share you about introduction on difference equation which comes for you in BSc Mathematics. Okay, so this is the first part and here this is my old notes. Let's go into the topic. So basically difference equation, everything. First we will see the definitions and then we will see some examples and then we will see some type of problems we are going to discuss. Okay, so first of all, definition: a difference equation is an equation involving independent variable and successive value or successive differences of a dependent variable ux. So difference equation அப்படிங்கிறது is an equation. Okay, so it involves what? It involves independent variable. First thing, okay, independent variable means it doesn't depends upon other variables for the values. Okay, so involving independent variables and successive value or successive difference of a dependent variable. So there are two kinds of variable, as you already know, independent variable and dependent variable. So in this the dependent variable ux will be there. Okay, so this dependent variable with successive difference will be there. So I will show you like how this means. Here u of x plus 2, here u of x plus 1 ux. It's like successive difference, right? So that is why a difference equation is an equation involving an independent variable, okay, and successive value or successive difference of a dependent variable ux. Then the order of the difference equation is a difference between the greatest and smallest surface of the dependent variable ux. So there will be a variable which is known as ux. Okay, so while you are finding the order, you have to find the difference between the greatest and the smallest surface of the dependent variable ux. Okay, you have to find the difference. This is just a definition. While we going into the problem, you can easily identify. Okay, so then the solution of the difference equation is a relation between the dependent variable x and independent variable x and dependent variable ux. So you are telling a solution to a differential equation means it is a relation between the independent variable and dependent variable. Okay, yes. So first, satisfying the given difference equation, given example. These are all difference equation examples. Okay. Then first we will see this. We will take this equation: del square ux plus 3 del ux plus 5 ux is equal to 4. Okay. So here it can be converted into a difference equation. Okay. Here I can convert this into a difference equation. So this is my question. Okay, so I'm converting this by ux plus 2. This del square will convert to x plus 2. Okay, then I will show you how this equation arises from this equation. Okay, basically I'm having a equation like this, so I can convert this del square as del into del, okay, ux plus 3 into del ux plus 5 ux is equal to 4. So I am going to write this del ux as ux plus 1 minus ux plus 3 into del ux as ux plus 1 minus ux. Okay, it's like successive difference. Minus 5 ux is equal to 4. So we have to add 1, okay, and then subtract that same thing. Okay, then bring this del inside. Del ux plus 1 minus del ux plus 3 ux plus 1 minus 3 ux here plus 5 ux is equal to 4. Here del ux plus 1 will convert into ux plus 2 minus ux plus 1 minus of del ux will convert to ux plus 1 minus ux plus 3 ux plus 1. Here we are having 2 ux, right? When you add, you will get plus 2 ux is equal to 4. Bring this negative symbol inside. So ux plus 2 minus ux plus 1 minus ux plus 1 minus will go inside. So plus ux plus 3 ux plus 1 plus 2 ux is equal to 4 will come. This will this will come down, and here you are having minus ux plus 1 minus ux plus 1 will give you minus 2 ux plus 1 plus 3 ux plus 1 will give you plus ux plus 1. Then here ux plus 2 ux will give you plus 3 ux is equal to 4. Okay, so here this must be a final equation after converting this everything. We should not directly convert that del square to ux plus 2 and then here to here. Okay, though, so it will not give you that perfect answer. First of all, you have to separate this del square as del into del. Okay, so again you have to bring this del alone inside here, del. Okay, bring this del inside and then again convert that into the difference equation. Okay, and here for this term you are just converting that and you are simplifying everything and you are getting the values like this. Okay, this is the equation you are getting in the end. In the example 1, the order will be like 2. Okay, because what you have to do is you have to subtract the greatest and the smallest dependent variable alone. So see here, to find the order of the difference equation is the difference between the greatest and the smallest suffix of the dependent variable. Okay, so what will come is x plus 2 minus x will give you 2. 2 is the order. Okay, here also what will come? This is the highest, this is the lowest. So x plus 2 minus x will give you 2. So the order is 2. Here the greatest is x plus 3 and the smallest is ux here. Okay, it is actually 7 ux. So minus x will come. If you cancel, you will get 3. Understood? So the order of the third difference equation is 3. Then here ux plus 1 plus 6 ux minus 5 ux minus 1 means the order is x plus 1 minus of x minus 1. Okay, this is the highest and this is the lowest. X plus 1 minus x plus 1. If you cancel, you will get it as 2. 1 plus 1 is 2. So the order is 2. Here ux plus 2 minus 5 x plus 4. Here ux plus 2 plus 10 ux means x plus 4 minus x will give you the order as 4. Okay. Next we are going to see general form of the difference equation. A difference equation of order r is given by ux plus r plus a1 into ux plus r minus 1 plus a2 into urx plus r minus 2 plus up to ar ux is equal to b. This is the difference equation. This is how we have to write the difference equation of order r. Okay, so here r will come r minus 1, r minus 2 till it will become 0, where a1, a2, ar be the constant. Okay, are the functions of f of x. This equation can also be written like this. R can move like e power r ux plus a1 into e power r minus 1 ux plus a2 into e power r minus 2 ux plus up to ar ux is equal to b. Likewise you can write. Okay, then you can take this ux as common outside. So er plus a1 e power r minus 1 plus a2 e power r minus 2 plus up to ar into ux is equal to b will come. So here what you can do is e of f of x is equal to, you can write it like f of x plus h. This is another form. Okay, when you have one e here and f of x here, if you want to bring this e inside, you can bring it like f of x plus h. Here e square into f of x means f of x plus 2h will come. Okay, so here we can write this as this is a function of e, right? Because we are having an equation which has e, right? So I can write it like f of e into ux is equal to b. Okay, where the shift operator, very shift operator, and f of e is a polynomial. What is meant by f of e? It looks like a polynomial, right? It looks like a polynomial in e of degree r, of degree r. So E of x plus 1 is equal to f of x plus 1. E of x plus 1 means the power of E is 1, right? So we can write it like f of x plus 1. Okay. Then E of ux means you can write it like ux plus 1. E square ux means you can write it like ux plus 2. So first we are going to see like difference equation of order 1, because ux plus 1 minus x will give you 1, right? So it is a difference equation of order 1. Ux plus 1 plus a into ux is equal to b, where a and b are constants or it's a function of x. Okay, so we are going to see type 1 here. Ux x plus 1 plus a into ux is equal to b. Here where a is equal to minus k and b is equal to 0. If this equation will satisfy this format, it comes under type 1. Okay, therefore the type 1 becomes ux plus 1, a becomes minus k into ux, and b is equal to 0, which is equal to 0 will come. Okay, I'm going to divide this equation by k power x plus 1. So divided by k power x plus 1 divided by k power x plus 1. See here, ux plus 1 divided by k power x plus 1. Okay, minus k into ux divided by k power x plus 1. So this 1 and this k will get cancelled, right? Because k power x plus 1, we can write it like k power x into k, right? So it will get cancelled. You will get it as ux plus 1 divided by kx plus 1 minus ux divided by kx is equal to 0. It's like difference, successive difference, right? So I can write this equation as del ux divided by kx is equal to 0. Bring this del operator to this side. So it will become ux divided by kx is equal to del inverse of 0. So del inverse of 0 will give you constant. Okay, so which is c. So what will come is ux divided by k power x is equal to c. Then bring this k power x that side. So ux is equal to c into k power x will come. So this is a solution for the type 1. Okay, for the type 1, the constant will become 0, and here the coefficient of ux will become minus k. Suppose if it was in the format, then you can write the solution as ux is equal to c into k power x. You can see this type 2 everything in successive videos. Thank you for watching. If you like this video, please like, share and subscribe to my channel. Thank you.